We're going to go ahead and talk about absolute value. Now, when you think about absolute value, if I gave you like the absolute value of A is equal to 5, remember absolute value is always distance from 0 on a number line. So if I put 0 here, that means absolute value of A is equal to 5. It'd be looking for numbers that are 5 units from 0. Well, there would be one number over here to the right, that would be 5 units to the right, or there would be one number to the left, which would be 5 units to the left, which would be negative 5. And so you get one answer where you get A is equal to 5, and then you get a second answer where A is equal to negative 5. And so what we have here is two outputs when you have your absolute value. Now, when you're looking at absolute value in general, you need to get absolute value by itself first. That's always got to be your first step. Now, what we were just looking at is like this here, where B is a positive number. You end up having two situations. Now, your first situation is like what we have over here in green, where it looks identical to what you initially had, just without the absolute value. And then you have your second one, where what was in the absolute value is equal to the opposite of what that was, and that's what we have here. So with absolute value equaling a positive, you're going to have two possible outcomes that you need to go ahead and solve each. Now, just as a side note, if I said absolute value of A is equal to negative 5, well, remember, absolute value is distance from the origin, and distance is always positive, where this is negative, so that means no solution. And that's what we're talking about down here. So we're going to go ahead and go through solving these absolute value equations. So first thing you have to do is get absolute value by itself, which it is. And then you have to write out your true situation. What's inside your absolute value is equal to 1, basically the original equation, just without the absolute value. And then you got to write out your second situation, which is what's inside your absolute value is equal to not positive 1, but negative 1. And then you have to go ahead and solve each one of these. So to get rid of dividing by 3, you multiply both sides by 3, and then you get m is equal to a negative 3. And then we got to do the same type of thing on the red. Multiply both sides by 3 to get rid of that dividing by 3. And we get this. These are both of your answers. So we're going to do that on the next one. Absolute value is already by itself. So we got to write out our two separate inequalities or equations. Now, instead of being equal to positive 1, it would be equal to negative 1. And then we just have to solve each one of these. So we have to add a 5 to both sides. And then we would get n to be equal to 4. Over here in the red, we solve that. We'd have to go ahead and add a 5 to both sides. And we get this. So those would be your two answers. So let's go ahead and take a look at this next one. The first thing we have to do is to get rid of or get the absolute value by itself. So you need to think, well, what's going on between the 7 and the absolute value? And that's multiplication. So to undo multiplying by negative 7, you have to divide both sides by negative 7. And then you write out what you have. Now, remember, absolute value is always positive. The right side here happens to be a negative. And remember, a positive can never be equal to a negative, so this is no solution. So, once again, we need to try to get absolute value by itself when we look at this next problem. We have a couple things going on here. We have a timesing by a 4, and we are having a subtracting of 1. So just think, if I gave you 4 times a minus 1 is equal to 79, if you needed to solve that, remember you'd have to undo the addition and subtraction first, and then you do the division. Same idea here. We'd have to undo our minus 1, so I'm going to add 1 to both sides. Then I have to undo that timesing by 4, so I'm going to divide both sides by 4. And I get my absolute value on one side by itself. Now, I end up getting 20 over here, which is positive, so then I can just work out my two separate equations again. I'll write out my first equation, basically the original equation, just without the absolute value. And then I'll write out my second equation, which is basically, instead of having my equation equal to a positive 20, it's equal to a negative 20. And then we got to just finish solving each one of these for x. I'd have to undo my plus 10 by subtracting a 10 from both sides. And then I'd have to undo my timesing by 10 by dividing both sides by 10. And I get minus 3. Then I still have to go ahead and solve the red one. So I'd have to do the same approach, so get rid of the plus 10 from both sides. Get rid of the timesing by 10. And I get 1. So these are my two answers. So that's what you have to do when you are solving absolute value equations. Now we're going to go ahead and start looking at inequalities. And then remember, inequalities often end up being shaded on a number line, where equations just give you 1 or 2 points on a number line. We have two separate ones here, so I'm going to go ahead and rewrite this one down below, and I'm going to write that out and then solve it. So I have to undo my positive 7 by subtracting 7 from both sides. Then I have to go ahead and divide both sides by negative 7. And remember, when you multiply or divide an inequality by negative, you need to switch your inequality sign. And then we all have to do the or, so we have to do the other one. And then I'll go ahead and solve that one. And I'll rewrite that one down below here. So I have to undo my plus 6, so I'll subtract 6 from both sides. Then I have to undo my 3, timesing by 3, so I'll divide both sides by 3. And so your answer with inequalities is this, but it also does say to graph. So if I graph the red says I have to be at negative 7, which is here. It's only a less than, not a less than or equal to, so that's an open circle. R is less than negative 7, so that's shading to the left. When I look at the green, that's a 6. That's a greater than or equal to, so that's a filled in circle, and R is greater than that, so I have to shade to the right. So that's what your number line would look like. Now, over here, when we look at this one, I'll just rewrite this down below. This is referred to as a compound inequality because you have more than one inequality in our original problem. Now we have to go ahead and solve this. So I need to get rid of this positive 3 by undoing that by subtracting a 3 from everything. Undo my timesing by 3. Now here we're dividing by a 3, so if you're dividing by negative 3, you'd have to switch your inequality signs, but we're dividing by positive 3, so you don't. So we get 5 greater than or equal to k greater than negative 8. So that's your answer when you are just solving it, but then we need to graph it. Notice we have 5 with a greater than or equal to, so that's a solid dot. We have our negative 8, and that's got a greater than there, so that's going to be an open dot. Notice with your inequality, k is in between these two numbers, so that means you need to then shade in between the two numbers we put on our number line. when we look at this next one here, we are going to need to get our v by itself, so you're going to have to undo that positive 2. So you're going to have to subtract a 2 from all three parts. Then you have to undo timesing by 8, so you're by negative 8, I should say. So divide everything by negative 8. And then you get 2. Remember, you're dividing by negative, so you got to switch your inequality signs. And then we have greater than or equal to's here, so you're going to have a filled in circle at your negative 4, filled in at 2. Notice your v down below here in the green inequality is in between your two numbers, so you have to shade in between your two numbers. Okay, so let's take a look at an example again before we get into the idea here. So suppose I said absolute value of a is greater than 5. Remember, absolute value is distance from 0 on our number line. So that means we're looking for all the numbers that are more than 5 units away. So that means you could be at 5, and if you're more than that, that would be shading here to the right. Or you could be more than 5 units the other way, so that would be here at negative 5 and then shading to the left. So when you look at these regions, we have a greater than 5, and then we have a less than negative 5. So you would have this one, and you would have this one here. Now the red one, when we were looking at this over here, is pretty much what we would have here. You get absolute value by itself first, and then you write your two separate inequalities. The red one is pretty much the same as your original, just without the absolute value. Now, when you write the green one, what was in the absolute value stays there, but you switch your inequality sign, and then instead of it being a positive over there, you put it as a negative. Once again, you need to get absolute value on one side by itself first. Now, if we look at another situation here, if we were looking at, say, absolute value of a less than 5, here would be 0 again, and then here would be 5, and here would be negative 5. Remember, absolute value means distance from 0, so we're looking for all the numbers that are less than 5 units away. So really, that's everything in between our 5 and our negative 5. When you are in between two numbers, you could write that as one compound inequality with your variable, which is a, in between. So in other words, this part right here is really just like your original, just without the absolute value. Then you end up putting down another less than sign, and then instead of putting down positive 5 over here, you put down the opposite of that number. So let's use these ideas down below to solve these absolute value inequalities. So let's go through this, and we need to get absolute value by itself, which in this case, absolute value is by itself. Notice it's absolute value followed by a less than sign. So that means it's going to be like this here. So when we rewrite this, I'm going to go P over 4 less than 3. Because it's followed by less than sign, then you have to put it as one compound inequality, and then instead of putting 3 over here to the left of the green, you need to put the opposite of 3. Now we have to finish solving this. Right now we are dividing our P by 4, so you have to multiply all parts by 4. So you get a negative 12, less than P is less than positive 12. So when you are graphing this, notice that you are only less than's, not less than or equal to, so they're going to be open circles. And your P is in between 12 and negative 12, so you're going to shade in between. That's what it would be for the graphing. When we look at problem number 36 over here, remember you have to get absolute value by itself. To get absolute value by itself, you'd have to undo that positive 9, so you'd subtract 9 from both sides. And then we end up getting the absolute value of negative 3r is greater than 6. Now you need to go ahead and get absolute value, or you got the absolute value by itself. Think of which situations do you have up here. We have absolute value followed by greater than. That's the top one up here. So you have to write it as two totally separate inequalities. So your first inequality is pretty much the exact original problem with your absolute value by itself, just without the absolute value. And then you go or, and then you can go ahead and do the second part, the negative 3r, switch your inequality sign, and then instead of positive 6, put negative 6. And then you have to go ahead and solve each one of these. Well, when you solve the first one here, you're dividing by negative 3. You get r to be greater than, r less than, because you're dividing by a negative, switch your inequality sign. When we do the green one, you also divide by negative 3, so you have to switch your inequality sign. And then you have an or statement in between. So now we need to go ahead and solve these. Or not solve these, but graph these. So when you graph the green, it would be an open circle at 2, shading to the right. When you do the blue, that would be an open circle at negative 2, shading to the left. And let's try a couple more here. Once again, we need to get absolute value by itself. Right now we are multiplying by a negative, so you'd have to divide both sides by a negative 6. And we end up getting n over 3 less than a negative 1. Now, whenever you get a negative on the right-hand side with your absolute value on the other side, you need to stop and think. Remember, absolute value is always positive. The right side is a negative. So the question is a positive less than a negative? Well, you should know a positive is never less than a negative, so it's no solution. So looking at the top right problem, you have to undo your, get absolute value by itself, undo that minus 4. So add 4 to get absolute value by itself. Then you have to decide which situation do you have, which is absolute value followed by a less than, so that's one compound inequality. So your first part's just basically absolute value with, or writing down the original inequality without the absolute value. And then you'd have to put another less than over here, and then instead of putting 16, you put negative 16. And then we got to finish solving this. So we'd have to undo our positive 4 by subtracting a 4 from everything. We get a minus 20, less than our negative 4x is less than 12. And then we need to go ahead and finish this by dividing everything by negative 4. Now, remember, when you divide by negative 4, you need to switch your inequality signs. So there are no greater than or equal to's or less than or equal to, so we know we have open circles at negative 3. And at 5, you'll notice in the purple, your x is in between, so that means you need to shade in between your two answers.